Today, I would like to share the analysis of last year Typhoon Ulysses hit on Philippines and caused severe damage. So uh, recently, we developed the observational network of rainfall and lightning in Manila area. So last year, the severe flood occurred in Metro Manila on November uh, 11th to 12th and caused a severe flood, especially around the Marikina River area. And this is the satellite image of the Typhoon Ulysses during the landfall. And the typhoon was generated over the Philippine Sea and propagated westwardly and landed on the 11th and passed north of Metro Manila at the time. So we are conducting a project called the ULAT SATREPS in the Philippines to develop the extreme weather monitoring and information sharing system in the Philippines, cooperating with the ASTI of Advances Science and Technology Institute from 2017. And during our project, we deploy the dense weather monitoring system in Metro Manila and wide lightning system in the Philippines to monitor the severe event like a typhoon and also the heavy rainfall. And we try to develop using this observational to make a short uh, term forecast in Metro Manila and also try to develop the sharing those observation information in the Philippines. So this is the weather observation equipment called Poteca we install in Metro Manila like this. So the weather elements has like radiation, rainfall, wind, pressure, temperature, and humidity. And we can observe these elements automatically without power by using the solar panel. And now we have 35 stations around the Metro Manila region. These are the numbers of each observation site in the Metro Manila. And this is the hourly rainfall observed during the Typhoon Ulysses on November 12th last year in the morning of a 1 hour rainfall. So you can see that all the stations measured more than 10 millimeter per hour and the orange areas shows more than 30 millimeter of a very heavy rainfall. And at the same time that the wind speed and wind direction observed in the early morning, you can see that a very strong wind, especially on the southern part of Metro Manila, exceeds more than 20 meter per second. And this is the sea level pressure observation from each station during the typhoon passage. Typhoon was located up north of Metro Manila, and you can see that all the stations show low pressure of less than 1,000
Ganda ng
hectopascal
boses
at
ni
the
Doktor
time.
Kubota.
So by using these automatic observation, we analyze 24 hours rainfall during the typhoon landfall. This is from on November 11th, 05 UTC to the next day of the 24 hours rainfall. And you can see that the heavy rainfall, more than 200 millimeter, was observed, especially around the northeastern side of Metro Manila. This plot includes the Pagasar observation of the Science Garden port area of different 24 hours rainfall. And Science Garden also measured more than 200 millimeters. So you can see the location of this area that Marikina River locates around this eastern part of Metro Manila. So the heavy rainfall mostly concentrated over this river basin area. So that caused a severe flood of this area. And when we closely take a look at one station, this is the hourly rainfall from November 11th to 13th. And mostly the heavy rainfall occurred on 12th, early morning and in the morning time. So the 24 hours of accumulation of rainfall in this station reached 221 millimeter of very uh, heavy rainfall was observed at the time. So these kinds of monitoring can be available by using uh, more than 30 stations in this area. So we try to share this kind of information by the real-time monitoring of this observation during our project. So next, we also monitoring the lightning. So when the lightning occurred, the electromagnetic waves propagates very widely around the Earth. For example, the very low frequency, when we choose this frequency area, the signal propagates around 3,000 kilometers. So when we install the receiver, we can detect the lightning occurred around 3,000 kilometers area. So we install this kind of instrument in the Philippine Sea area. One of the instruments we install in Palau, of the east of Philippines, uh, so the measurement that we use this kind of dipole antenna can observe the lightning. And this is one sample of the lightning detection of the event trigger measurement. And from this observation that we measured only the uh, maximum amplitude and its time, and also the minimum amplitude and its time. And using this small amount of data that we can send the real-time data by 3G communication, and it is easy to handle for the analysis. So at least we have several stations that we already have at the Palau, Guam, and two stations in Japan, and also the Metro Manila, the Science Garden, we installed the lightning detection observation, and one in Indonesia. So when we have several stations that, for example, the geolocation of lightning can be detected by using the time of arrival method. It is uh, the time difference between two stations of the one lightning can show this kind of line. And others two stations like Palau and Manila, we can make another line. And Manila and Guam time difference, we can make this kind of line. So at least we have three stations. We can identify the location of this time lightning occurred at this station. So using this method, we analyzed the lightning location during the Typhoon Ulysses. This is the plot of lightning during November 11th. These black dots represents the location of Typhoon Ulysses. It was just landed and propagated westward at the time. And these color crosses is the location of lightning. So you can see that the blue colors of the eastern part and the red colors on the near the coastal area. So it means that the blue occurs first and late at the time it occurs westward. So it means that the lightning locations also propagate westward on this day. And this kind of everyday location of lightning, we are already uh, available on online in the test stage. It's still a test stage, but you can watch this kind of lightning every day from this website. And this is the everyday location of lightning during Typhoon Ulysses from November 8, 9, 10, 11, and 12. Uh, Typhoon Ulysses was generated on November 9 and on here, and there was another previous typhoon on the South China Sea on Typhoon Tonyo at the time. And when the Typhoon Ulysses developed, you can see those lightning locations of each day. So when we make analysis of this lightning locations, this is the time series of Typhoon Ulysses from November 8th to 13th. The black line shows the intensity of Typhoon Ulysses. So on November 9th was Typhoon Genesis. And this plot, the center pressure, it means that the low pressure shows more intensified typhoon. And the landfall on the November 11th, just before the landfall, the Typhoon Ulysses reaches its maximum intensity. And the same plot that this blue line shows the lightning frequency observed within 500-kilometer radius from the typhoon center. So you can see that more numbers of lightning before, half a day before typhoon genesis, and also the just around the typhoon landfall. And the upper panel shows the same time series, but the lightning frequency from this is 0 means the typhoon center and 1,000-kilometer distance from the typhoon center. So just before the genesis, the many lightning occurred around 500 kilometers from the typhoon center. And before the landfall, you can see that the lightning occur around 200 to 500 kilometers, and the more lightning occur around 500 to 700 kilometers from the typhoon center. When we take a snapshot of this is the uh, cloud image from Himari 8 and from during the typhoon genesis on November 9th, one every hourly, that 00 UTC, 01, 02, 3, 4, 5. And at that time, the was just before the development of Typhoon Genesis. It was the tropical disturbance uh, stage, and the center was located on here. Philippines are around here. And at the same time, the lightning location can be plotted of this kind of uh, black crosses. So during the genesis, that the mini lightning occurred on the northwest of the tropical disturbance center. You can see like this. And this is another plot of during the typhoon landfall. The date is November 11th from 03, 09, 15, and 21 UTC. And the location of typhoon is around here and was landed around this time. And the lightning was occurred on this time was northeast of the typhoon center and mostly occurred over the ocean of the coastal area during the typhoon land. So you can see that the lightning of during the typhoon Ulysses, this is a cross section from 120 around here, this box, to 132 of this area, the lightning frequency, from November 9th to 13th. The location of Typhoon Ulysses propagates westward by 9th to 12th around this area. And the frequency of lightning can be seen on the east part of the typhoon center. So it means that on the backward part of the typhoon, the mostly lightning occurred. These kind of observation was become available from this lightning observation. So it was like summarize that the dense rainfall observation network in Metro Manila and wide lightning observation network over the western North Pacific was constructed by our ULAT satellite project. And during the Typhoon Ulysses landfall, the heavy rainfall was observed, especially around the morning of 12 November, and more than 200 millimeter of rainfall was accumulated in 24 hours around, mainly around the Marikina River area. And the lightning was intensified during the Typhoon Genesis and also during the landfall, and mainly occurred around the Philippines area. And this kind of feature can be seen in other typhoons in last year. So in our project, we will develop this observation network and try to share this real-time observation of the not only rainfall, the weather observation, and also the lightning in near future. Thank you very much.